welcome back to my channel. This video is made under the special request of Dear Ayesha. I hope this video can really help you to understand about this topic. You are welcome to let me know in the comment column if there is any math topic that you need help. Please subscribe my channel for more math topic coming up soon. Look forward to your response. In this video, I'm going to talk about domain and range of a function. The domain of a function f of x is represented by the set of values of x such that this function f of x is defined. The notation for domain is D, capital letter D represent domain. F is the function f of x. If the function is g of x, then dg. So df is equal to, now normally we use set notation to mention the domain. So here we have a set of set brackets here, and since domain is the values of x, so here we use x dot dot means where x is the elements of real number. So what is real number? Real numbers are the number that can be represented by a point on the number line. So let's say we have the number line here. So any number that we can plot a point on the number line, that is real number. For example, 0.123. So 0.123 you can plot somewhere here. Okay, for example 1/2, so you can plot the point 1/2 here, and so on. So for example, square root of 2. Square root of 2 generally is 1 point something, so you can plot the number somewhere here, square root of 2. Okay, for example, e is the number that is 2.718, so you can plot the e somewhere here. So means square root of 2 is real number, 0.123 is real number, 1/2 is real number, e is a real number, where you are able to plot a point on the number line. Now for the range of the function f of x is represented by the set of values of y, where y is equal to f of x, and this is based on the domain value of x, and the range is denoted by the capital letter R here, and F. R is range, F is the function f of x, and same thing, we have to use set notation to mention about the range. And since this one is range, is the set of value of y, so we use y, where y is the real number. Then after that, for domain and range, we need to mention what are the values of x that make this f of x defined, and what are the range of value of y based on this value of x. So now before we go to the example, we look at the method. Actually, we have two methods to mention about domain and range. One is by using set notation, one is by using interval method. Now for example, this one, the first one, for the domain, here I use domain to do the explanation, so I use x. If you want to mention about range, so here you have to use y. So for example, x, the domain is x, where x is real number, means the domain is all the value of x. Okay, then in interval, okay, you know that all the value of x means the x is from negative infinity up to positive infinity. That is all the values of x. So when we change to interval, we can use the brackets form, start from negative infinity up to positive infinity. Okay. Then number 2, if you want to mention the domain is less than 3, then after that you have to tell that x is the real number. So less than 3, 3 is not included. If x is less than 3, let's say 3 is here, so less than 3, so if you put under interval or brackets form, so means we start from negative infinity up to 3. And if 3 is not included, then we use a round brackets to represent that 3 is not included. In case 3 is included here, so here you have to use the square brackets to represent that the x is less than 3 and included 3. Then if you want to tell that the x is all values of x except you have one value not acceptable, that is 3. Okay, you don't want to accept 3. Other than 3, all the values you can take. So you can say that x is all the value of x except 3. So x is not equal to 3. Other than that, all the value of x can be accepted. So this is by set notation form. If we use under interval form, so you can break into 2 interval, because 3 is the number that cannot be taken, so that is under empty circle. So on the left hand side we use one bracket, then on the right hand side we use the other bracket. So the brackets on the left hand side, it is from negative infinity up to 3, but not included 3, so that's why there is a round brackets here. Then and the other half of the brackets then start from 3 but not included 3, then up to positive infinity. So this is the method we use, interval method. Then number 5, if you want to mention that x is in between two number, one is negative 2, one is 3, and where negative 2 is included, 3 is not included. So when we use interval form, since negative 2 is included, so beside the negative 2 that is square brackets, 3 is not included, so beside 3 that is the round bracket. Then number 6, negative 2 is not included, 3 is included, so beside negative 2 is round bracket not included, square bracket means 3 is included. Then number 7, both are included means both we use square brackets. Then if you want to mention x is greater than or equal to, so same as this one, we start from 3. Since 3 is included, so we use a square bracket, then up to greater than 3 means from 3 up to positive infinity. Then if 3 is not included, then 3 is round brackets. Then for infinity will be always round brackets. Okay, for infinity we won't use square brackets for positive infinity and negative infinity. Now we look at the example how to find the domain in range by using graphs. Now here we can see we have some of the graph of the function. Based on each graph, we try to find out what is the domain and range of this function. So now we start from the first one. First graph is the reciprocal function. Now in order to find the domain, you can imagine that you simply draw a straight line, okay, that is vertical straight line. Let's say it is negative 2 here. So if this straight line intersect with the curve, so means this negative 2 is one of the element in the set of domain. So if you continue draw the straight line, let's say this is negative 2, so negative 1. So if the straight line intersect this curve means negative 1 is one of the element of the domain. So when we continue drawing all the straight lines, so you can see that all these straight lines intersect with the curve. So means this value here is part of the domain. So but except one value, when you draw the straight line, that straight line will not intersect with any part of the curve. That is this one. So when you draw a straight line somewhere here, this straight line will not intersect with this curve on the left hand side and the curve on the right hand side. So it means this value of x is not the domain. So this value of x is x equals to 0. So generally we can see all the value of x when you draw the straight line can be intersect with the curve except this x value. So means the domain for this function is x for domain dot dot x is not equal to 0. Okay, so x is equal to 0, it is not the domain. Other than the value of 0, the other value, that is domain. So means domain is all the value of x but except 0 is not the domain. Then as for range, okay, to find the range also the same thing. To find the range, you can imagine that you draw a horizontal straight line. Now if you draw a horizontal straight line somewhere here, so this horizontal straight line will intersect at one of the dot with the curve. So this value of y is accepted as the range, one of the value of range. So, okay, somewhere here, so this is also range. When you draw horizontal line here, so this part of y also range, but except one value, when you draw the horizontal straight line, that horizontal straight line does not intersect with any part of the curve, that is this one. So this one is y equal to 0. So it means the range of this function is y, where y is not equal to 0. Other than that, all the value of y, that is range. Now we go to B. Same thing, if you want to find the domain, we imagine when we draw a straight line somewhere here. So you can see that even though somewhere here means the curve is extended, so this vertical straight line intersect with the curve here, intersect with here. So all the straight line, when you draw straight line, will intersect with the curve because curve is continuous like that. So you can see that all the value of x will intersect with this curve. We don't have any other value of x that does not intersect with the curve. So for this example, the domain is all the value of x. Okay. Now we go to range. Okay, range, same thing. We imagine we draw the horizontal straight line. So when we draw the horizontal straight line, so somewhere here, okay, so the horizontal straight line intersect the curve here. Yes, so this one is included in part of the range, intersect. But when you come to this part, okay, so this part, this horizontal straight line does not intersect with any part of the curve. So start from this point. This is the minimum point. Okay, when y it is equal to -2 is the minimum point. Then less than -2, the horizontal line will not intersect with any part of the curve. So means the range is for all the value of y that is greater than -2. For y is less than -2, that is not the range. So we can say that the range is y, where y must be greater than -2, included -2. So y must be greater or equal to -2, and where y is the real number. Next we go to C. So same thing, if you want to find domain, you imagine that you draw the vertical straight line. So when you draw the vertical straight line, all these vertical straight line will intersect with the curve. So means in this example, the domain is all the value of x. Now as for range, same thing. You can imagine when you draw a horizontal straight line, any horizontal straight line, where if the horizontal straight line intersect with the curve, yes, that is the part of the range here. Okay, so but when you come to a point here, when you come to y equals to 3, it is still intersect with the curve, but it is when you continue going up, see here the horizontal straight line will not intersect with any of the curves, so means this part is not the range, but the y is less than 3, so means for this function the range is y less than 3 and included 3, because at the 3 the horizontal straight line still intersect with the curve, so included 3 and y is the real number. Now in this example, we are asked to find the value of the domain and range for the following function, but the graph is not given. So in this case, we need to sketch the graph by our own. So first we go to A. A is f of x equals x squared minus 3x plus 2. So this one is a quadratic function. So first we need to factorize, since we are able to factorize the quadratic. So after factorize, we will get 2 linear factor here. Then we can start sketching the curve by using the linear function here, linear factor here. So first we mark the x 1 and 2. Since this one is positive quadratic, means the shape of the curve is an U shape, so we draw the U shape. Then after that, we need to find the value of the minimum point, and we know that the minimum point is at the axis of the U shape. So in order to find this value, that is the value in between 1 to 2, so that is 1.5. So minimum point is at this when x it is 1.5, so you substitute x when x is 1.5 into the equation. When x is 1.5, y is 1.5 squared minus 3 times 1.5 plus 2. When you press the calculator, it is negative 1 over 4. So means the minimum point is negative 1 over 4. Now after sketching the graph, now you can find the domain of this function. So in order to find the domain of this function, you just imagine you draw the vertical straight line. You find that when you draw the vertical straight line, so all the vertical straight line can intersect with the curve. So means the domain is all the value of x. As for the range, you just imagine you draw the horizontal straight line. All the horizontal straight line are able to intersect except below the minimum point. So means the range is greater than negative 1 over 4 for this fx. Now we go to question B. B is f of x equals e power 2x minus 3. So this is an exponential function, so we can start sketching the graph by using the transformation method that we have learned before. So first, the parent graph is an exponential function. Then from the parent graph, we carry out the x transformation, that is 2, so means it is the enlargement for 1 over 2. So for enlargement 1 over 2, you know that the scale factor is less than 1, so the image will get nearer to y-axis. So after the enlargement, that is the curve for e power 2x. Next, we go to -3, means that is the y transformation, shift the whole curve going down for 3 units. So now when shifting down for 3 units, the horizontal asymptote of the explanation will come out up to y equals -3 is the horizontal asymptote. Then the curve will shift down. So now this is the curve for this function. Now from here we can find the domain. So domain, you can imagine we draw all the vertical straight line. So when we draw any vertical straight line, that will intersect with the curve. So the domain is all the value of x. Now as for the range of y, so on top of y equals -3, all the horizontal straight line will intersect with the curve. But when you come to below -3, so the horizontal straight line will not intersect the curve. So means the range of y is greater than -3, but not equal to -3, because -3 is the horizontal asymptote. Now we go to question C. Question C is f of x equals logarithm 2x minus 1. So generally the shape of logarithm is same as ln. So means we start sketching graph from the parent graph, which is logarithm x, but the shape is same as ln x. So ln x, generally the shape is going up, and this is 1. Then from the parent graph, we start doing the enlargement. For 1 over 2, the scale factor is 1 over 2. So when scale factor is 1 over 2, so the image of the curve after the enlargement will get nearer to the center, which is y-axis. So after the enlargement, this critical point initially is 1, will shift to 1 over 2, because 1 will multiply with the scale factor, it is 1 over 2. So the new intersect is at 1 over 2. So after enlargement, this value is 1 over 2. So after that, we go to log 2x minus 1. Since this 2x minus 1, it is inside the brackets of the x. So means minus 1, that is the translation for x. That is either shift to the left or shift to the right. So in order to determine shift to the left or right, we simply make it equal to 0, and in order to find the value of x, if the value of x is positive, means we need to shift the curve to the right hand side. So means we need to shift the whole curve to the right hand side for 1.5 unit. So means initially 1 over 2, after half unit shifted to the right, so becomes 1. Then after shifting, we know that the vertical asymptote will also come up for 1 unit, 1.5 unit shifted to the right hand side. Because shifting to the right hand side, the vertical asymptote will come out initially, that is hidden behind the y-axis. So after the translation to the right, the vertical asymptote come out from behind the y, that is for 1.5. So x is equal to 1 over 2 is the vertical asymptote. So after shifting, the curve will come to the right, and the intersect here becomes 1. So now this is the curve for this logarithm of 2x minus 1. Now we can find the domain. So now imagine we draw all the vertical straight line. Now before 1 over 2, the vertical straight line won't intersect any curve, so that is not the domain. Then after 1 over 2, the vertical straight line will intersect with the curve. So means the domain of this function is greater than 1 over 2, but not equal to 1 over 2, because 1 over 2 is the vertical asymptote, which is cannot touch the curve. Now we go to range. So you imagine you draw all the horizontal straight line, so all the horizontal straight line are able to intersect with the curve, so means the range is all the values of y. Now we go to question D. Question D is a modulus function, which is gx equals modulus of x minus 5. Now in order to sketch the modulus function, we start from the function which is without the modulus. So means we sketch y equals x minus 5. It is a linear. So when x is 0, y is negative 5. When y is 0, x is 5. So from here, then we go to modulus. So modulus means for the part of the graph which is below the x-axis, we just reflect the graph up. So after the reflection, the graph which is on top greater than 1, we don't touch, we just reflect the part which is below the graph. So after reflection, so this is the graph. Then from here we can find the domain. So when imagine we draw all the straight line, vertical straight line, we find that all the vertical straight line are able to intersect with the graph. So means domain is all the value of x. As for range, we find that the horizontal straight line below above the 0 are able to intersect, but below the 0, the horizontal straight line won't intersect with the graph. So means the range is greater than or equal to 0, because at 0, the 0 still intersect with the graph. So the range is y greater than 0 and equal to 0. Now we go to question E. E is a square root function where gx it is equal to square root of x plus 2. So now we start sketching graph from the parent graph y equals square root of 2. So the parent graph y equals square root of 2 is a curve going up here. So from here, then we go to x plus 2. X plus 2 means we do the x translation going to the left, because when we find that x is negative 2, so shift to the left for 2 units. So after sketching the graph, now we can find the domain. Now imagine you draw all the straight line. For the straight line, vertical straight line on the left of negative 2, we won't intersect any graph. So after negative 2, the vertical straight line will intersect the graph. So means the domain is greater than negative 2 and equals to negative 2. Then as for range, the horizontal straight line will intersect the curve on top of x-axis. Below the x-axis, no intersection. So means the range is y greater than 0. Now we go to question 3. Question 3, you are given the function f as square root of 2x minus 5. So now we sketch this graph. Start from the parent graph square root of x. From square root of x, we go to square root of 2x. 2 means the enlargement of x-axis. That is scale factor is 1 over 2, which is less than 1. So means the image will be nearer to the y-axis. So after enlargement, the graph is this way. Then after that, we go to minus y. So minus y, it is inside the bracket. So that is the x transformation. So means we shift either to the left or to the right. So in order to decide whether it is left to right, so we try to make it equal to 0. We find that x it is positive 5 over 2, which is 2.5 steps. So shift to the right hand side because positive. So means the graph, we need to shift the whole graph to the right hand side for 2.5 up to 5/2. Okay, now after shifting, we can find the range. Now when we look at this diagram, so we can see that initially the domain of this function is x greater than or equal to 5/2, and initially the range of this function is greater than or equal to 0. But because of the question already changed the value of x, so this is the new domain for this function. So where the question already changed the domain to x greater than or equal to 3. So if domain change, the range also change. So means we need to find out when x greater than or equal to 3, how about y? So first we mark the 3 here. So this is, we need to find the value of y. So we sub x equals 3 into y to find out what is y. So we find that y is equal to 1. So when x is 3, y is 1. And from the new domain, it is given that x is included. So then the part of the graph that is asked for this question is greater than 3. So this is the graph that we use this part of graph to find the range. So now from this graph, to find the range, we draw the horizontal straight line, even though below here it is intersect with the curve, but this curve we don't want because of the new domain. The curve start from 1, so means the range should be also start from 1. So when we draw the horizontal line, the horizontal line will intersect the curve here, and this one we don't want because the domain has already changed. So when domain change, the range also change. So finally the range is greater than or equal to 1. Thanks for watching.